It's your boy DK underscore typical TV, and today we're going to be working with the Arduino Mega today. The use of materials, the bill of materials, should I say, that we'll be working with is obviously the Arduino Mega. We're going to be working with a VEX servo, a VEX potentiometer, two VEX push buttons, a VEX DC motor, a battery pack, a VEX motor controller, and use a piece of tape as well as a metal axle. Alright, in our first exercise 6-1, the objective of this was essentially to get familiarized with the Arduino Mega. We pretty much had to attach an analog and digital VEX component to the Mega, and also utilize the LCD screen. As you can see right here, it being dark shows me that it was essentially wired in a negative way, so I had to change my code up. Later on you'll see the code be a lot brighter. I figured it out after the fact, but it's kind of hard to tell what it's saying, but if you had to look real close. But essentially we had to use the push button, and when we press the push button on that LCD screen, it'll show you pushed it, and then also with the motor it'll show you the potentiometer value that would be displayed on there. If you look closer, you can see it change a little bit. I know it's kind of hard to tell, but yeah, the analog value for the potentiometer is second to the bottom, and then the push button's all the way at the bottom. So yeah, as I'm turning the analog, or turning that potentiometer, the analog value, which is the potentiometer value, is changing, and when I press the push button changes from press to not press on the screen. Now here's my code. As you can see, it's pretty not pretty, but since we had to use a separate zip file for the liquid crystal to use the LCD screen essentially in this exercise. See, as you can see at the bottom, I have the analog value A0, which is the potentiometer, and the push button is a digital read on pin 2. Yep. And on to the next exercise. On the next exercise 6-2, we're basically starting to use the servo motor in this one. So the objective of this exercise was to limit the range of motion in a servo motor, or had to set a limit range in how the motor turns and whatnot. So as you can see, the servo motor I have the axle in the motor, and it's changing at different degrees. So it's from 0 to, I believe, what was it? 0, 45, 90, 135, 180, and 90. Different degrees, as you can see on the code here. This code is programming the servo motor, which you saw that had a little flag on it, change at different degrees. Yeah, servo main's up the top. Servo main attached is 41, because I had the servo motor going in the pin 41 on the Arduino Mega. And on to exercise 6-3. We're pretty much continuing with the servo motor, but in this exercise, we're pretty much going to be controlling the servo motor. We're going to be using pretty much we're using a potentiometer to control the servo motor in this one. So in this code, you see the map value, because we had to use a function in the code to change the potentiometer value so it's able to read in the servo motor. So the potentiometer reads from 0 to, I believe, 180, and so we had to map that for the servo motor. So as the potentiometer value changes, you see as I'm turning the potentiometer, the axles. Now as for the code for this exercise 6-3, we like I said, we had to use a mapping function so we could change the so we could change the potentiometer values into values that the motor itself can understand. So the potentiometer read from 0 to 180, and so we mapped that to 0 to 1023 so the motor can understand those changing values. So next exercise 6-4, we're working with DC motors. Now in this exercise, we're essentially replacing the servo motor, and we're pretty much having it turn on and turn off. So as you see, when I press the one button, it goes one direction, and I press the other button, it goes in the opposite direction. As you can see, I have it set to where motor right is pressed. When they're not pressed, the screen, the LCD screen, shows you they're both not pressed. Now when I press one, it shows you push button 1 is pressed, and when I press the other button, see it's still going because I'm pressing the first button. Now when I press the second button, you'll see the bottom go push button 2 is pressed. So then the flag or the axle will turn in the opposite direction. So with this exercise, this exercise was fairly simple working with DC motors. So when now when you look at the code here, so I essentially have each push button as an input. So a lot of the LCD prints and set cursor is to set the LCD screen and give that. So then what I put is, I put an if else statement. So if the one button's pushed, it goes in one direction. But if the other button is pushed, then it goes in the opposite direction. And then when no button is pressed, it turns off, so the motor doesn't run at all. All right, then last exercise 6-5, we're pretty much doing a conveyor simulation. So in this exercise, we're essentially having one button start the motor. We're having the potentiometer control the speed of the motor, and then the second button cuts off the motor completely. So as you can see, it's on, and I'm changing the potentiometer and the flag speeding up, slowing down. So as you can see on the LCD screen, I have it where conveyor is running, the motor speed. I have two values. I have the motor speed, and then I have the potentiometer value just to give me some, I guess, reference point. See, so as you see, the motor's moving. I press the stop button, the motor starts off. Press the button, it turns on, and I turn the potentiometer so the speeds up, slows down, and then I stop it. This code was a little tricky because we had to involve PWM, and it's pretty straightforward. Just I think we had to not learn it again, but had to review it to really fully understand it because we were having troubles in previous labs. But yeah, this I used the if. I believe, what was it? If I used pretty much 3 ifs. So if the push button 1 is pushed, and I threw a variable out there just to start the second one. So if the first push button is pressed, it goes to the next one. It follows along into where the potentiometer controls the speed of the motor, and then if the second push button is pressed, it cuts off the motor completely.